right, this is lesson 2.8, and this is the one that we skipped, so we're going to go ahead and cover this before we cover any other sections in chapter 3 because we have to know this stuff first. So graphing linear inequalities, you have seen this before in Algebra 1. Maybe it has been a little while. But what a linear inequality is it's like a linear equation, but with the greater than, less than, greater than or equal to, and so forth symbols in there. So with these symbols, greater than, less than, greater than or equal to, less than or equal to, instead of that equal sign. Boundary is a line that divides the coordinate plane into two halves. So one side contains all the solutions. The shaded region, as you can see over here is our example, this shaded and this boundary line. So that is containing all of our solutions, that shaded region. So how do we do that? How do we graph that? Well, we first need to get it into kind of that slope-intercept form, pretending like that's an equal sign. Now, one thing we do have to remember is that if we divide or multiply by a negative number, we have to switch our inequality sign. So that should be a reminder when we were solving those. That still applies when we're changing things around, getting ready to graph it. Negative over negative changes it to a positive 1/2, and then -2. So we're going to start at -2, put a dot. Move up 1 over 2. Now we have to pay attention also to if there's a line under here. That creates a solid line. If there's not a line, which in this case there isn't, it's going to create a dashed line. So we want to make sure our line is pretty long, going stretching all the way across. And then we're going to look to see, since this says y is greater, that means we're going to shade above. Now think of it like an escalator, how you're at the mall riding an escalator. So the above part is the part where you would be riding, and then the below part is where the mechanics are. So for above, if we were to ride this escalator, we would be here riding it. So this is the above part, so we would shade all the above. All right, this next one, we're actually not going to graph it. We're just going to write the inequality, and then we'll answer example B. So we have a combined score of 900. So let X represent the verbal and Y represent the math. So our combined 900 or less. So that X plus that Y, the verbal and the math, have to be less than or equal to 900. And that just gets a little bit hard to graph since we're only at tens here for that 900. So we're going to skip that graphing part. Does a student's verbal score of 480 and a math score of 410 fit? So let's go ahead and plug those things in. So 480 plus 410, is that less than or equal to 900? So if we add those two together, we get 890. And is 890 less than or equal to 900? Yes. So yes, that would fit the guidelines. All right, so we already kind of talked about the inequality symbols and what they mean, but if we have something that's less than, we know it's going to be a dashed line because there's no line underneath there. And then if it's less, we would shade below. Now if it is greater than, we're still dashed, but greater means we're going to shade above. And then we have a less than or equal to, which is now going to make it a solid line, still shading below because it's less than, and greater than or equal to, solid line shading above. So we're going to decide on this next section if that is the correct graph. So first we need to see if it's graphed correctly. Start at -1, move up 1, 2, 3 over 1. Yes. This should make it a dashed line. Yep, it's dashed. And then y is greater. So we look to see, did they shade the escalator part where we would ride? Yes. So this one, yes, they did it correctly. Let's look at the next one. Start at -1. Put a dot, move down 1 over 1. Yep. Solid line because of the line under there. Perfect. And it says y is greater, so we should shade above. So again, riding the escalator. Uh-oh. This is the above part where we would ride, so this part should be shaded. So not this part, so no. The shading is incorrect. Next, x is less than 4, so that's going to be our going through the x-axis at 4. That's correct. Dashed line because there's no line underneath there. That's correct. X is less. So that means we want to shade, and since it's a straight up and down line, we think left as less, just like a number line. So yes, that one is correct. So let's go ahead and practice a couple of these. Absolute value, very similar to the linear. Think back to your transformations, and you're going to first come up with your coordinate pair of where to start. So nothing inside 0, -2 outside. So we're going to start at 0, -2, and we're going to draw a V. Now the lines still apply to our solid or dashed. So this one's going to be a solid V. So we're going to go ahead and draw our solid V there. And get my V right. There we go, sort of. All right, now we determine, do we, and I should actually pull this out some more, and it would be right there. There we go. Okay, now we're going to decide, are we going to shade inside or outside? And here's the way we can do it. We're going to test 0, 0 to see if it works. And if it does, we'll shade in here where 0, 0 is. So if I plug a 0 and I get -2, is 0 greater than or equal to -2? The answer is yes, 0 is greater than -2. So this is a point, which means all this in here, those are solutions. So we shade inside. Go ahead and try the next one on your own. Remember to come up with the starting point and then use your slope of 3, and this is going to be a dashed V. And then shade. So pause, try that one, and then check your answer. So hopefully you started at -1, 0 with a slope of 3, and then you had a dashed V, and then you should have tested 0, 0, and if we test 0, 0, 0 here, 3 times the absolute value of 1 is 3, and 0 is less than 3. So 0, 0 does work, which means everything outside of the V is your solution because there's 0, 0.